So a Hamming code is a linear code. We're basically going to be using the 7-4 Hamming code as an example, both for quantum error correcting codes and classical error correcting codes. But most of what I'm going to say applies to all linear codes. And there are lots and lots of linear codes that are better than the Hamming code. So I'm going to tell you what the Hamming code is, why it works, how to encode, how to correct errors, and how to decode. And what is the Hamming code? Okay. So this is a generator matrix for the Hamming code, and it's going to look like 1. These are all zeros. And then we have, let's say, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1. And this is going to correct one error. And how do we, well, what is this? The code words are the row space mod 2. To encode m times g. So now we're multiplying vectors by matrices on the right, which is what we have, the opposite of what everything I've been doing in quantum computing. And the reason I'm doing this is the way that information theory does it, well as multiplying them on the left is the way that quantum mechanics does it. And my brain is too petrified to switch. So suppose we have 1, 1, 0, 1. So suppose that's our message. Okay, to encode mg, what we do is we multiply it by this matrix, which means we take the first plus the second plus the fourth column. Row. So it's row 1 plus row 2 plus row 4. So that's in the row space. And the first 4 bits, you multiply by the identity. So this is equal to 1, 1, 0, 1. And the next 3 bits, it's 1 plus 1 plus 0 for the 5th bit. So that's a 0, because 1 plus 1 is 0. The 6th one, it's 1 plus 1 plus 1. So that's 1. And the 7th one, it's 1 plus 1. So that's 0. So this is how you encode. And for linear codes in general, there's always, you can always find a generating matrix and encode it by multiplying the message by the generating matrix. Yeah?
So in this case, you're basically just transmitting the original message plus some sort of checksum.
Right. Yeah. And this, in fact, is called parity check. And this is called, and you can call this the message. So exactly right. So it looks like you've added redundancy here. And it means, looks like you've duplicated information. But in fact, we'll show how to do this We'll show how to do quantum error correcting codes which don't actually duplicate any information. And you can, if you're bored with this, if you've seen classical error correcting codes before, you can spend the rest of this class figuring out how could you do this quantum mechanically without actually duplicating any information. Although even when you see the formula for quantum error correcting codes, you have to really think about why does this not duplicate any information.